Alright, so in this video we're going to look at adding forces, and we're going to get on to using scale diagrams to add forces. So we've got three people pulling on a metal ring. Joe pulls with a force of 100 newtons in one direction, Daniel 140 in the other. If the ring doesn't move, what force does Helen exert if she pulls in the same direction as Joe? So that's a lot of text. Let's turn that into a diagram. So we've got 140 one way, 100 going the other, and then Helen must be helping out the 100 Newton force. And we can clearly see that X has to be 40 so that the resultant force is 0. Okay. So a boy drags a suitcase along the ground with a force of 100 newtons. If the frictional force opposing the motion is 50 newtons, what is the resultant force? So here's our diagram there. The resultant force, or the sum of F, as I use a symbol, is just going to be 100 minus 50. If the suitcase has a mass of 18 kilograms, calculate its acceleration. So Newton's second law says the resultant force is equal to mass times acceleration. So we rearrange that, plug our numbers in, and we get 2.8 meters per second squared. A picture is supported by two vertical strings. If the weight of the picture is 50 newtons, what is the force exerted by each string? So if it's not moving, the resultant force must be 0. So those two forces added together must be 50, so each force must be 25 if they're identical strings. Calculate the value of the missing quantity in each of these examples. So in the first diagram, we can clearly see we haven't got A, so we want to calculate what it is. So we're going to use Newton's second law. So the resultant force here is going to be 25 minus 4, and that gives us 6 meters per second squared. The next diagram, we don't know the mass. So again, we're going to be using Newton's second law, but we rearrange to make mass the subject. And then once we do that, we end up with a mass of 5 kilograms. Okay, so this one, we want to know what the forward force F is. So what I'm going to do is calculate the resultant force using mass and acceleration first of all, 2.625. So we know that F minus 8 must be equal to that. So therefore F must be 2.625 plus 8 gives us 11 newtons when rounded. The next diagram, we want acceleration. So again, we're using Newton's second law. Again, rearranging to make acceleration the subject. This time, we're going to end up with a negative resultant force, because you can see the backward force is greater than the forward one. So we get an acceleration of minus 3 meters per second squared, or a deceleration, I guess, of 3 meters per second squared, assuming it's traveling to the right. Using a scale of 1 centimeter to represent 10 newtons, find the size and direction of the resultant force of 30 newtons and 40 newtons. So 30 newtons is going to be a 3 centimeter line, 40 newtons is going to be a 4 centimeter line. So those of you who know your maths should know that the hypotenuse is going to be 5, because we've got a 3, 4, 5 triangle. But we can actually take the measurements from it. So I got PowerPoint to tell me how long that arrow was, 5 centimeters, which means the force is 50 newtons. And then the angle you just measure using a protractor, and with the angle you can see I've given it to the 3 centimeter force. So we've got two forces acting at point O. By scale drawing, find the magnitude and direction of the resultant force. So the key thing is, just as we just did just now, the vectors or the forces need to go tip to tail. And it doesn't matter which way round we put first. So we could put the 5 first, we could put the 8 first. And what we do is we form a resultant force parallelogram like this. And the resultant goes from start to end, goes across there. So I'm going to give the angle between the resultant and the 5 Newton force. There would be nothing wrong with giving the angle between the resultant and the 8 Newton force. You just have to specify which is which. So I've given that. So I've measured the length, 7 centimeters. I used a 1 centimeter to 1 Newton scale. So that gives us 7 newtons. And then I've got the angle is 40 degrees to the 8 Newton force. Okay, so again by scale drawing, find the resultant of each pair of forces below, state the magnitude and direction. So again, we can form our force parallelogram by adding the vectors tip to tail. Again, the resultant goes from the start to the end, and I'm going to give the angle between the resultant and the 15 Newton force. Okay, so this is my diagram here. So I've got R is 11.9 centimeters, and I did every centimeter is 2 newtons as part of my diagram. So that gives us 24 newtons. And then we've got X is 11 degrees to the 15 Newton force. I just used a protractor to measure it. Okay, so final drawing. So we've got our two forces again. Again, we go from tip to tail. So we go 40, then 50, or 50, then 40. Form our force parallelogram. Resultant goes from start to finish. And again, I used a 1 centimeter equals 10 Newton scale. So my resultant is 3.6 centimeters, so 36 newtons. The angle is 55 degrees to the 50 Newton force. And that completes using scale diagrams to determine resultant force.